Java 17 is a long-term support, LTS, release. It brings powerful new features, performance improvements, and security enhancements that every Java developer should know. In this video, we break down everything you need to know about Java 17. Java 17, released in September 2021, is a long-term support, LTS version, ensuring extended updates and stability. This version introduces significant language enhancements, optimizations, and security improvements while deprecating outdated features. Let's explore each feature in detail, using theoretical examples to understand their real-world applications. Language enhancements. 1. Sealed classes, JEP 409. Concept. Sealed classes introduce a new way to restrict inheritance, allowing only specific classes or interfaces to extend a parent class. This ensures controlled extensibility while preventing unintended subclasses from modifying the behavior of an API. Theoretical example. Imagine designing a financial system with different types of accounts: savings account, checking account, and business account. If you want to limit the creation of new account types beyond these, you can use sealed classes. In the past, any developer could create new subclasses of bank account, potentially leading to inconsistent implementations. With sealed classes, only savings account, checking account, and business account are allowed, ensuring strict control over inheritance. This feature helps in API design where a fixed set of subclasses is expected and prevents unauthorized extensions. Pattern matching for switch, preview. JEP 406. Concept. Traditionally, Java's switch statement was limited to primitive types, string, and enums. Pattern matching extends it to work with object types, allowing more concise and readable decision-making logic. Theoretical example. Consider a payment processing system where different payment types such as credit card payment, bank transfer, and crypto payment exist. In traditional Java, handling different payment types would require explicit casting and instance-if checks, leading to verbose code. With pattern matching, the switch statement can automatically determine the type and execute the appropriate logic. This makes code more readable and eliminates manual type checks, reducing the chance of errors. Strongly encapsulated JDK internals. JEP 403. Concept. Java has been moving towards strong encapsulation by restricting access to internal APIs. Many applications previously used reflection to access private JDK classes, leading to security risks and maintenance issues. Theoretical example. Imagine a third-party logging library that relies on Java's internal sun.miscellaneous unsafe class for performance optimization. In previous Java versions, such access was permitted with warnings. In Java 17, access is strictly denied, forcing developers to use public APIs instead. This change enhances security, maintainability, and future-proofing, ensuring that applications do not rely on hidden implementation details. Performance and optimization. 4. New macOS rendering pipeline, JEP 382. Concept. Java applications running on macOS traditionally used OpenGL for rendering. However, Apple has deprecated OpenGL, and Java 17 now introduces a new rendering pipeline using Metal API, improving graphics performance. Theoretical example. Consider a desktop-based Java application, such as a financial dashboard with data visualization. Older Java versions using OpenGL may suffer from slower rendering and visual artifacts. With Metal API, the application sees smoother graphics, better GPU utilization, and improved energy efficiency. This is especially beneficial for GUI-based applications built with JavaFX or Swing, making them run more efficiently on macOS. Foreign Function and Memory API, Incubator. JEP 412. Concept. Interfacing with native code. Example. C libraries has traditionally been done using Java Native Interface, JNI, which is complex, slow, and error-prone. The Foreign Function and Memory API provides a safer and more efficient way to call native code and manage memory. Theoretical example. Consider a high-frequency trading application that needs to communicate with native C++ trading libraries for real-time order execution. Using JNI, the application experiences high overhead and security risks. With the new API, it can access native memory directly and invoke functions safely, leading to faster execution and reduced risk of memory leaks. This is particularly useful for applications that need high-performance interoperability with native systems. Deprecation of Security Manager, JEP 4.11. Concept. The Security Manager was originally introduced to restrict permissions for Java applications, especially applets. However, modern security solutions such as sandboxing and containerization have rendered it obsolete. Theoretical example. Consider a Java-based web server running in a cloud environment. Previously, the Security Manager was used to restrict file access and network permissions. In modern deployments, security is handled by cloud provider policies, container isolation, Docker, and access control frameworks. By deprecating the Security Manager, Java encourages developers to adopt modern security practices, making applications more flexible and portable. Garbage collection and JVM enhancements. Z Garbage Collector, ZGC. Enhancements, JEP 391. Concept. The ZGC is a low-latency, scalable garbage collector designed for applications that require consistent response times. Java 17 extends its support to macOS and Windows, making it more widely available. Theoretical example. Imagine a real-time analytics platform processing millions of events per second. Traditional garbage collectors cause pause times, disrupting performance. ZGC ensures that garbage collection runs concurrently, reducing application delays and improving throughput. This is particularly beneficial for cloud-based applications, databases, and financial systems requiring real-time responsiveness. Improved G1 Garbage Collector, JEP 375. Concept. The G1GC is optimized to reduce pause times by handling memory more efficiently. In Java 17, region pinning improvements further reduce performance bottlenecks. Theoretical example. A Java-based e-commerce platform with high transaction volume. During peak sales events, traditional garbage collection can cause delays in order processing. With improved G1GC, memory is managed more efficiently, keeping the system responsive under heavy load. This makes Java 17 more suitable for scalable, high-performance applications. Deprecated and removed features. Deprecation of Applet API, JEP 398. Concept. Java applets, once used for browser-based applications, are now completely deprecated as modern web technologies. JavaScript, WebAssembly, have replaced them. Theoretical example. Previously, online stock trading or banking portals used Java applets for secure authentication. Modern platforms now use web-based authentication, OAuth, JWT. Instead, applets were dependent on browser plugins, which are no longer supported. Deprecating applets ensures Java stays focused on modern web development trends. Removal of experimental AOT and JIT compiler, JEP 410. Java experimented with ahead-of-time AOT compilation and just-in-time JIT optimizations, but due to low adoption, these features are removed. Instead, GraalVM and Project Leiden are the preferred solutions for performance optimization. This keeps Java's core leaner and more maintainable. Deprecation of RMI Activation System, JEP 407. The Remote Method Invocation, RMI, activation system, once used for distributed computing, is deprecated as modern alternatives like gRPC, REST, and Kafka are preferred. This aligns Java with modern cloud and microservices architectures. Why upgrade to Java 17? LTS support for long-term stability, better performance with ZGC, G1GC, and memory optimizations, modern security practices without outdated mechanisms, improved cross-platform support, including Apple M1 compatibility, more expressive code with pattern matching and sealed classes. Let me know if you would like a deep dive into any specific topic. Don't forget to like, comment, and subscribe for more Java updates.